Thank you for your interest in LinearBench Analyze, the industry's first comprehensive LRS data analysis software from Gistic Research. LinearBench Analyze is powered by patent-pending, grid-based LRS segment join technology. Analyze makes complicated tasks, whether LRS analysis or LRS QC, accessible to all users with its intuitive UI design. A complete commercial off-the-shelf solution, LinearBench Analyze offers several advantages. It can be deployed without the need for data model migration or data conversion. It features asynchronous communication, which enables continued use while multiple lengthy analysis operations are underway. And Analyze is fully integrated with LinearBench Explore, Gistic's LRS data visualization software. This integration allows for further exploration of generated reports in its straight-line diagram, time-space diagram, and map tools. Our demo of LinearBench Analyze consists of 2 videos. In this first video, I'll demonstrate the software's LRS analysis capabilities. Part 2 will cover its LRS QC operations. Analyze appears as a separate tab in LinearBench Explore. In the left panel, parameters are set to define the route or route segments to be analyzed, the operation to be performed, and the resulting report. At the bottom is a grid that contains saved analysis reports and their settings. The center of the window displays the results of a selected report, and on the far right is the map panel, which spatially displays those results. I'll begin by conducting an overlay analysis using the Arizona Department of Transportation's Roads and Highways data. The overlay operation is best described as a joining of layers in the spatial or spatiotemporal domain. This graphic will help to illustrate the 4 possible join types. We'll start with 2 layers, an AADT layer and a projects layer. If you select an inner join, the result will be the records occurring on the route only where the selected layers overlap. Notice, though, how the resulting records are dynamically segmented to reflect changes in the layer value combinations. If you select a left join, the result will be all of the records in the first layer, plus the records resulting from the overlap of the 2 layers. Similarly, a right join will return all of the records in the second layer, plus the records resulting from their overlap. And a full join results in all of the records of the selected layers, plus the records resulting from their overlap. For this overlay demo, I'll select ADOT's US 60 to analyze. In ADOT's system, all US route names are preceded by the letter U. After entering a U followed by an asterisk in the route filter, I can easily find US 60 in the route dropdown. Once selected, you'll see it in the Selected Routes area. Next, I'll open the Operations Definition area and select the analysis operation to be performed. Here I'll select Overlay. I'll then select 4 layers: Speed Limit, National Highway System, Access Control, and Functional Classification. Once the layers are selected, you can specify how they should be joined. For each layer, I'll select Left Join. That is, all of the records of the first layer and the records of the next layer that overlap with it. I must then select the attributes I would like to include in the report. To do this, click here in the Attribute column, and all available options for that layer appear in the drop-down. I can pick more than one attribute for a layer by clicking the Add icon to insert a second row. Once all attributes have been identified, I can move on to the report definition step. By default, the application adds a prefix to the report name to identify the operation performed. Analyze can also recommend a report description, which can be viewed by clicking the Use Recommendation checkbox. Just uncheck that box if you want to modify it. Last is to decide the report's scope. If you select Private, the report will only be viewable by you. I'll make this one public to share with others. To begin the analysis, I'll click the Generate button. You may have noticed the score and symbol groups drop down in the operation definition step. This parameter is used only for the overlay and summarize operations. When selected, you're able to set a weight, the number of symbology groups, and minimum and maximum values for selected attributes that are used to compute an evaluation score for each resulting record. The management authority responsible for the Central Arizona project in Arizona plans to use this feature to evaluate aqueduct bank conditions along its 336-mile-long water delivery system. In this example, the result of a 6-layer overlay with weighted score is displayed in the straight line diagram. The sections with higher scores warrant more frequent maintenance activities. To help illustrate the results of our overlay analysis, let's view them on the straight line diagram. I've already entered a segment of US 60 and selected the 4 individual layers that make up our analysis. I can now scroll to the lower section of a layer drop-down to find all of the analysis reports available to me. Here's our overlay report. I can select it like any layer to see it graphically displayed on the straight line diagram. The original analysis for all of US 60 resulted in 120 records, but when filtered for miles 70 to 85, it's 14. Each row corresponds to a segment in the resulting analysis layer. The data grid includes columns with segment ID and measurement information, as well as columns for each of the layer attributes selected in the operation definition step. As you can see from the straight line diagram, we don't have National Highway System data for the full range selected. The report result supports this by including several records with a null value for NHS. Had we picked inner join, the segments with no NHS value would not have been included. The last analysis operation I'd like to demonstrate is summarize. It calculates useful statistics of a source layer over a reference layer. In this illustration, we're looking at speed limit data in relation to projects data. The results of the summarization analysis appear in the darker green boxes and include statistics such as the minimum and maximum speed limit values, in addition to a length-weighted average and predominant speed limit. Here's an example. I'll use Utah DOT data to calculate basic crash statistics on I-15, I-70, and I-80 over an AADT layer. First, I'll select those routes. After selecting Summarize as the operation, I'll need to decide whether I want to see accident data summarized over equal length segments or another layer. I'll select Reference and the AADT layer in the Reference dropdown. I can then select crashes as my source layer and crash severity and number of vehicles involved as the desired attributes. In the settings grid, you can set the number of symbology groups the 2 attributes will be broken into. Here I can change the default number for both from 4 to 3. Once the report has been defined and run, I can select it in the Reports grid to view the results, first here on the Analyze tab. As you can see, the operation returned 199 records. Each record includes columns for the min, max, average, and length predominant values for both crash severity and number of vehicles involved. I can view the location of any record on the map by clicking its corresponding checkbox. Let's look at a subset of this report on the Straight Line Diagram tab. On I-15 from mile 100 to 350, the report returned 86 records. The legends for each displayed attribute can be viewed in the Visual Aids window. It's interesting to see that between miles 265 and 350, the average crash severity is lower, depicted by the gold color, while the number of vehicles involved is higher, as indicated by the predominantly red color. But this can be explained when we see that this is occurring in a more congested urban stretch of highway with higher AADTs and lower speed limits. I just want to quickly mention that Analyze also includes gap and overlap operations, though I won't describe them in detail here. These operations use the overlay function, but are different in that they apply only to single layers. This is the end of part 1 of our LinearBench Analyze demo. If you would like more information about LinearBench Analyze or any of the other LinearBench Suite products, please send us a message from the contact page on our website or give us a call. Thank you for watching.